Yes, hello students. In this lecture, we will learn how do we do the implementation and the explanation for the multiple linear regression. Okay, so shall we go to the explanation for multiple linear regression? And after the looking at the theoretical explanation, okay, so we can see that how do we do the implementation of the multiple linear regression. So let me share my screen with you all. Okay. So first, you should know what is the difference between the simple linear regression and multiple linear regression. So simple linear regression, it helps to assess the relationship between one independent variable and one dependent variable. But in the case of the multiple linear regression, okay, so you'll be able to assess the relationship between more than one independent variable. So if there is only one independent variable, then that is called a simple linear regression. But if there is more than one independent variable, then that is called as multiple linear regression. So mathematically, when we do the representation, obviously, depending upon the number of variables in the input, number of features in the input data set, you can add the variables and extend the mathematical representation. Y is equal to b naught plus b1 into x is the representation for the simple linear regression. For the multiple linear regression, okay, so according to the number of features, okay, the representation can vary from y is equal to b naught plus b1 into x1 plus b2 into x2 until bn into xn. So, what are all the general uses of multiple regression? This might be used to identify the strength of the effect that the independent variable have on the dependent variable. So, when there is a rate of change in the independent variable, and what is the impact in the change of variable of the dependent variable? Say, for example, you want to estimate what is the price of the house based upon considering the different features in the input. Maybe what is the total number of rooms in the houses, and what is the square feet for each and every room, and what is the lawn area, and what about the locality, whether it is nearby the hospital and the school. So, this helps to assess, identify the strength of effect that the independent variable have on the dependent variable. And this also helps to understand how much will the dependent variable change when there is a change in the independent variable. Okay, so according to the change, okay, so when there is an if your house is having a very good locality, so if it is depending upon the situation, depending upon the distance to the schools and the universities, the price of the house will increase. So the multiple linear regression analysis, this also helps to do the prediction of the future trends and the future value. So how is the economic trend? So if you would like to predict what will be the profit of the organization, considering the different features as an input. Okay. So for the multiple linear regression, okay, so this is the data set what we are going to even practically work on with. So let us consider, for example, so you take into consideration, so profit is going to be the dependent variable. Okay, you are going to determine the profit by considering what is the amount the organization spends in research and development, in the administration, in marketing, and where is the locality of the state. So this organization, okay, so it locates in nearly two different locations. One is New York and California. So this input data set is having a categorical value. So it is always when you're working on, okay, we see that you should make the computers to understand. And you also have to understand that for the regression, the input have to be numerical and output also will be numerical. So since it is going to be a categorical, you can introduce a dummy variable. So say for example, Okay, so this one particular column is divided into two columns. One is New York and the California. So, in the first column, wherever the New York is present, it is given the value, it is assigned the value as 1, and wherever California is available, it is given the value as 0. Okay, and obviously the second column is going to be California. So, wherever California is there, it is given the value as 1, otherwise, 0 is provided. So, obviously, with the help of the dummy variable, okay, so you can exclude one of the column, okay, and you can obviously you can have only one of the column because it makes sense to each and every one of us. If the organization operates in New York, it doesn't operate in California. So if the organization doesn't operate in in New York, it's going to operate in California. So with one of the column itself, you can understand what is going to be your the value for the other column. So mathematical representation for this multiple linear regression, y is equal to some constant plus b1 into x1. x1 is R&D, b2 into x2, x2 is administration, b3 into x3 is marketing, b4 into d1 plus b5 into d2. So, by introducing the dummy variable trap, okay, so it is always good for us to eliminate, in case if there is two variable, you can omit one of the dummy variable. So when there is more than one value, okay, so mathematically according to the t-test, we take calculate the statistical significance called as p-value. Okay, so that is like p is equal to, you fix up the threshold as 0.05 for all those features whose value, if it is less than 0.05, it is of highly significant. If it is greater than 0.05, it is going to be less significant. Okay, so we are going to consider, so we see that x1, x2, x3, x4, x5, x6 and x7 different features are there. So it is not important for us to include all the features. So only those features which has an impact in the prediction of the output variable, we are going to consider those feature. Okay, so what are all the methods for us in order to do the selection? So one is like you take every feature as it is and do the prediction. And the second is according to the requirements. Say for example, if you're going to developing this model for a particular organization, so you need to come up with a brainstorming session to find out which are all the features that is important from the perspective of the organization. So this can be called as a different method called as, you can keep either all-in method, you can call it as backward elimination or forward selection. It is bidirectional elimination that includes both forward and backward and score comparison. So all in case is like you can keep all the features, okay, or having a prior knowledge according to the application whatever you run. So what according to the requirements, to the need, you can select those features that is needed. And the backward elimination is you have to fix up a significance level to stay within the model, which is equal to 0.05, and need to fit the model with all possible predictors. Okay, so predictors is the features. Okay, so predictors are nothing but features. So we need to consider the predictors with the highest p-value. Okay, so highest p-values, those features having the significance level greater than 0.05 have to be eliminated. Okay, so we need to remove that predictor. This is called as backward elimination. And the other one is forward selection. We need to select a significance level to enter into the model, and the same level according to the t-test, we are going to assume that the value is equal to 0.05. So we need to fit all the model and we are going to select the one with the lowest p-value. So we need to try to keep the variable and we need to possibly try to fit all the model with one extra predictor. Okay, so and here also we see that the predictor with the lowest p value is selected for getting trained into the model. If the p-value, if it is the predictor's p-value, if it is less than the significance level, we need to go to step 3. Okay, step 3 is we need to keep that variable and we need to try to fit the model with those features. Otherwise, we can go to finish. So these are all some of the method. Okay, so one is the last one is bidirectional elimination. Okay, so as I've told that this includes both forward selection and backward elimination. Okay, so we see that no new variables can enter and no old variables can exit. Okay, so here also you can have a significance level for each and every predictor, or you can call it as a feature to stay within the model. Okay, so this is about your multiple linear regression. So this is the type of a model that is used when you have your more than one feature is given in your input data set. That is the difference between the simple linear regression and the multiple linear regression. Okay, so the next we'll learn about the implementation of the multiple linear regression. Thank you all.